Hi dear students. So today we have a new chapter in front of you. Okay, this is I could say the very fundamental of organic chemistry. So I can give you one promise here. So if you learn this chapter thoroughly, all other organic chapters is just a walkthrough. It's very easy actually, because this forms the fundamental and this describes how an organic compound behaves basically. Okay, now we know that we are now able to learn history, geography, or whatever be the subjects, physics, chemistry, all because we know the fundamental language English, correct? If you are learning in a medium English. Why we know that? Because in our LKGs or first standard we have learned the letters, we have constructed words, then we formed sentences out of the words, we learned grammar. Because of all these things, we are now able to read and understand that language and anything that is written in English. Similarly, to understand organic chemistry of any other chapter, this behaves like the same thing. Okay, so you should learn this chapter very thoroughly, spend the maximum time, try to do the maximum questions, so that organic chemistry becomes a cakewalk. I can promise you that. Okay, now before we go in depth into this chapter, let's say I have divided this chapter into 4 sections. Okay, you can say section 1. Section 1 is where we are learning about what is the branch organic chemistry, who is the base, which is the basic element that forms the backbone of organic chemistry, why it forms like that, why can't be the other elements. These reasons we will look into it. We will look into how to name an organic compound, what are the different types of naming available. Okay, then we try to understand the concept of hybridization with respect to organic chemistry. Okay, hybridization we will explain in detail in a chapter called chemical bonding, but here with respect to the carbon that forms the fundamental of organic chemistry, so we will explain the hybridization of the carbon and how to understand the hybridization of different compounds in organic chemistry. These things we will discuss. Next we will go to the concept of aromaticity, very important, whether the classification of organic compounds, in that aromatic and non-aromatic, anti-aromatic concepts will come into picture. Those things we will discuss and understand. So that is the section 1. Okay, that is the fundamental, very fundamental. Then we go to the next section 2 that explain the property of organic compounds. One of the most important property of organic compound is isomerism. So what are the different types of isomerism? Structural isomerism, stereoisomerism, optical isomerism. In that further more classifications are there, conformations. So we will go into detail the section 2, that is basically the different types of isomerism. Okay, and we will go to the section 3, that is, I would say, the key part, very important part. This you should not miss. Okay, this explains the electronic effects. Electronic effects means whenever you are forming an organic compound, how will the bond break basically, or which bond may break actually, or what are the types of attacking reagents, what are the different types of effect that is present in an organic compound, like inductive effect, electromeric effect, resonance effect. Okay, many different types of effects, that is called electronic effects. Next comes the reaction intermediates. When an organic compound undergoes reaction, whether all the reaction will happen in one single step, or whether there is a reaction intermediate is there, or basically how the reaction happens, or I can generally say this whole section as reaction mechanism. Very important. This can be told as reaction mechanism. Okay, very important section with respect to organic chemistry. So many students used to say, sir, I need to by heart all these organic reactions. Very difficult, sir. Sir, I will say, don't by heart any organic reactions. If you know this section, reaction mechanism section, you will predict, sir, this bond will break and I hope this product will be formed. This is how you will start telling. Okay, very important section. And last, the section 4, that is the classification of organic reactions. So when you learn different types of organic reactions, we say we will put it under different names. So we will try to classify. Once you learn this, you will understand, okay, oh, alcohol, right, sir, alcohol means it will only undergo this reaction. Haloalkane, sir, it will undergo nucleophilic substitution. Like that, you will keep on saying like that after you learn the section 4. That is very important section. And you can see one thing I have written in red color, that is the qualitative and quantitative analysis, that is purification of organic compounds and detection of elements. These things are right now I don't know whether it will be present in the syllabus for the next NEET exam, because they are cut shortening the syllabus. So as part of it they may remove this section. But for safety side we will have a look into that also, okay, but we will go into in depth into the syllabus. We will check whether if it is required only I will teach you, don't worry about it, okay. So this is the general idea, what and all things I am going to give to you as part of this chapter. If you need more anything outside this, you can contact me, I will help you, but this is what your syllabus prescribes, okay. Now let's start with the section 1, that is introduction, section 1, that is the nomenclature, hybridization and aromaticity. We will start with that, okay. So hi students, so let's start with the first section, that is section 1. So first we will deal with history of organic compounds, very important, okay. So we can say, I will define what is an organic compound. I can say an organic compound is generally hydrocarbons and their derivatives. So from the term hydrocarbon you will understand, hydro means hydrogen, carbon means carbon, the element carbon. So anything that is made up of carbon and hydrogen, they are called hydrocarbons. So all hydrocarbons are generally what? Actually organic compounds. And we say hydrocarbons and their derivatives. Why we say their derivatives are also organic compounds? Because we have functional group which is made up of elements other than carbon and hydrogen. Something like elements like oxygen will come into picture, where we have functional group like OH. So in that case we say hydrocarbons and their derivatives. Nitrogen may come into picture in amines. So we generally say hydrocarbons and their derivatives are called what? Organic compounds. Now looking into the history, we can say the first classification was happened in 1675. That was by Nicolas Lemery. Nicolas Lemery, he classified the chemical substances into 3. That is, the first one is called mineral substances, where you say gold and all those like stuffs. Vegetable substances. Vegetable substances include many things actually. Animal substances. Animal substances are something like what you can say, gelatin. Gelatin is an animal substance. And vegetable substance you can say something like sugar, all these substances, okay. But later it was understood that those things which they considered as vegetable substances can obtained from other substances as well, like animals. From animals also it can be obtained. So they understood like this classification is of no use, because this is failed completely, because as per this classification a substance is classified as vegetable substance if it can be derived only from vegetables. But they understood that this can be sometimes derived from animals also. So that's the reason why this was a failure actually. This classification was a failure. So they went into the new classification. So in new classification, chemical substances are classified mainly into 2. So one was organic compounds and the other was inorganic compounds. So here their understanding was they defined organic compounds as those compounds which were obtained from living origin. That means from living beings basically. And inorganic compounds are some substances which are obtained from non-living substances. Okay, this was the criteria they followed actually. Okay, but this classification also in future they thought all organic compounds can be obtained only from where? Living substances. And this theory was a popular theory which was put forward by another person called Berzelius. So just I will write that. Okay, so I can say there is a person called Berzelius who proposed a theory called vital force theory. Okay, what is the theory name? Vital force theory. So I can write Berzelius in 1815, very important, remember the year, put forward the theory called VFT. VFT stands for vital force theory. Okay, so he put forward the theory which is called vital force theory. So let me explain what is vital force theory means. Vital force theory is very simple. They told that since organic compounds are obtained only from living beings, and we know that living beings are created by whom? God. Okay, so instead of putting the name God, they told it's a mysterious force that is called vital force in the name of science actually. So they say Berzelius he proposed a vital force theory that states that all organic compounds can be derived only from living beings. and or it is present inside the living beings, and these living things are created by a vital force, and this theory is called vital force theory. Okay, and later what happened was, this was disproved actually. This theory also went into failure. Who disproved it? That is also very important. There is a German scientist, very important, German scientist. His name is Hohler. Okay, Hohler. His name is Hohler. He disproved this theory in 1828. 1828. How he disproved it? Okay, I will write here. Disproved. He disproved VFT. Very important. So he disproved the vital force theory. So what he told is, what Berzelius told is not completely correct. It is possible that an organic compound can also be synthesized outside a living matter. That means inside a lab. Or it can be prepared from an inorganic compound. Inorganic compound, that is non-living. They thought like it is obtained from non-living things. So he proved that from ammonium cyanate. Okay, I will write here ammonium cyanate. Please remember this compound. They may ask in entrance. NH4CNO. Ammonium cyanate. When it undergoes rearrangement reaction, rearrangement on heating. So ammonium cyanate, which is an inorganic compound, okay. So this is an inorganic compound which on rearrangement changes to NH2CONH2. This is nothing but an organic compound named as urea with a molecular mass of 60. Okay. So he proved that you can prepare an organic compound. I will say this is an OC, organic compound. Okay, very important. So he proved that an organic compound like urea can be synthesized in lab from an inorganic compound called ammonium cyanate, NH4CNO. So this discovery actually disproved Berzelius' vital force theory. Okay, so thereafter you understood that from once the organic compound was synthesized in lab, they started preparing many organic compounds. Soon we understood that organic compound become the backbone of pharmacology or pharmaceutical chemistry. And nowadays we are all having antibiotics and all those things which are nothing but our organic compounds. So this is a very important branch with respect to medicine, and in first year you are learning a chapter, you need to learn a subject called biochemistry, where you need to know the fundamentals of organic chemistry, very important. Okay, so this is what you need to remember. Wohler, he is a German scientist. In 1828 he disproved the vital force theory, and this was with an inorganic compound ammonium cyanate. It undergoes rearrangement reaction to form the first organic compound that is synthesized in lab. That is nothing but our urea, NH2CONH2. Molecular mass will come around 60. Okay, so we just went through the history a little bit, that's it. Now next we will discuss why carbon forms the fundamental backbone of organic chemistry. Okay, so dear students, let's see what is the importance of carbon in organic chemistry. I told you that carbon forms the fundamental backbone of organic chemistry. So why we say that? Why can't it be other elements? So we will try to see the reasons why it is. Okay, the first reason I can say here is the tetravalency. That is, the valency of the carbon is being 4 actually. Why? Listen here. Suppose you can take the element like sodium. Sodium, what is the atomic number? It is 11. So 2, 8, 1. That is the electronic configuration. So to become stable, to attain stability, what it needs to do? It needs to remove one electron so that it will form 2, 8. Correct. So on removing an electron, what is basically it is achieving? Stability. So I can say that is an electropositive element. Why? Because on removing an electron, it will become electropositive. Why it becomes electropositive? Its number of protons becomes greater than number of electrons. So we say it is electropositive in that case. And the type of bond which is formed by completely donating an electron to someone is called ionic bond. Okay, it is one of the strongest bond. We will learn about the different types of bond in chemical bonding. Okay, and we know that chlorine's case also we know. What is the atomic number of chlorine? 17. That is 2,8,7, right? So to attain stability, what it will do? It will attract one electron and it will become 2,8,8. Correct. So here it has attracted an electron. Correct. So once it attracts an extra electron, what it will become? It becomes electron negative. Why? Because the number of electrons becomes greater than the number of protons. Correct. So, but in the case of carbon, the atomic number here is 6 actually. That is 2,4. So it doesn't know whether to donate the 4 electrons or to gain the 4 electrons to attain stability. In that case, carbon will do a special thing that is called sharing of electrons. It will share these 4 electrons with someone else, so that it will also get 1 electron from the shared compound, so that it can attain stability. Understood? So this sharing is an important feature. So it can share with anybody who is capable of who is ready to share with this. So that is one main reason why carbon, it forms the fundamental of organic chemistry, or we can say organic compounds are present in large quantity. Okay, listen here. So atomic number of carbon is 6. So it has 4 electrons in its valence shell. So its valency is equal to 4. So carbon, I can say 1s2, 2s2, 2p2. Okay, don't worry, I haven't taken new atomic structure. I will explain how to write this electronic configuration. Okay, just now you believe 1s2, 2s2, 2p2. And valence shell means the last number out of this. This is 1 and next number is 2. So last number is 2. So what and all things are, how many electrons are there in shell 2? You can see 2 electrons here, 2 electrons here. So I can say 4 electrons are present in the what shell? Valence shell. Okay, and the ground state configuration of carbon is the 2 electrons are present in the 2s shell and 2p orbital has 2 electrons, 1 electron here, 1 electron here. But actually the 2p orbital, the p orbital is of 3 types: px, py, pz. This we learn in atomic structure. So here one orbital can hold a maximum of 2 electrons. Since only 2 electrons are present, here only 2 electrons you can see. Understood? So in the ground state configuration, it can donate only 2 electrons. You can see here, these are the 2 electrons which needs pairing, or it can share. It is already shared. But in the excited state, first excitement means when you provide energy, the electrons in the valence shell jump in such a way that to undergo maximum sharing. So here these electrons will get excited and it will go to this orbital. So here how many orbitals are available for bond formation? 1 2s orbital is there and 3 2p orbitals are there. So it can form either bond for it can form different types of hybridization. I will explain those things, don't worry. So it can form either this orbital can link with this orbital, we say sp, or one s orbital can link with the 2p orbital, then we say sp2, and one s orbital can link with 3 other p orbitals, we say sp3. Like that, 3 possible hybridizations are possible for carbon. That is, please remember, sp3, sp2 and sp. We will go into the hybridization a little bit in the chapter chemical bonding. What is basically hybridization? I will explain you. Okay, just now you believe that, very simple, carbon, it has tetravalency is one main reason why carbon is able to form the backbone of organic chemistry. Okay. Now the tendency to form multiple bonds, we know that the valency of the carbon is 4. So if you see here, it can form single bonds, 1, 2, 3, 4. So 4 valencies are satisfied, one bond is formed of 2 electrons. And please believe that this 1 electron comes from the other element due to sharing. So it can form bonds like this. Sometimes it can form double bonds. You can see here carbon, here also you can see 1, 2, 3, 4. So the valency still hold good, and when one more electron come from the other elements, so it will become how much? Again 2, 4, 6, 8. So this will also attain stability, and similarly this element will also attain stability. And similarly it can also form triple bond. So in triple bonds here you can see between carbon and carbon 6 electrons are shared and 1 electron is shared with an extra element. So here also 2, 4, 6, 8. It has attained stability. So single bond it can form, double bond it can form, triple bond it can form, and even it can form 2 double bonds simultaneously. So it can form double bond with another carbon, so 2, 2, 4, 6, 8. It can form 8 electrons. So this configuration is also possible. So a carbon have giving options like this much type of bond formation. So that is another most reason why organic compounds are present in large amount, and that is also one reason why carbon forms the fundamental of organic chemistry. So next we will see the third reason. So the third reason we can say it as the tetrahedral shape of the carbon. So we know that whenever the carbon it forms single bond. Okay, so the basic hybridization of the carbon will be sp3 hybridization. In that case, the shape will be tetrahedral shape, and we can say that the 4 covalent bonds will be directed towards the four corners of a regular tetrahedron. Okay, so here what is the advantage? We say that since it is directed towards the 4 different corners, there is always more probability that it can form, it can donate, or it can share electrons with the nearby elements. That is the advantage of having a tetrahedral shape actually. Okay, next one, catenation, the most important property. So whenever in exam they say, give the 4 options, why carbon forms the backbone of organic chemistry, they will give the option A, tetrahedral shape, option B, they will say tendency to form multiple bonds, and option C, they will say tetravalency, and option 4, catenation. I will always say go for catenation. I will tell what is the reason. Listen here. So catenation means what actually? The self-linking ability of the carbon. It can link always with the other same element. I have shown you carbon can link with the same carbon either through single bond, double bond, or triple bond. So that self-linking property of the carbon atom is called catenation, and here it can give rise to either open chain compounds. For example, it can be like this. Carbon will form open chain compounds like this, or it can form closed chain compounds. How? It can form compounds like this. Correct? So these are closed chain compounds. So I can say like this, it can form closed chain compounds also it can form. So like this, carbon it is capable of self-linking with each other, and we need to understand that by experimentally it has proved that the catenation energy, or we can say if you take different elements, carbon, silicon, nitrogen and phosphorus, the catenation energy if you say in kilocalorie for bond formation, it is maximum for carbon 85 kilocalorie. That is favoring for catenation. That is another important reason why carbon forms a fundamental. So the most important property being catenation. Okay, other properties are also there, but give priority to catenation. And sometimes some textbook will also say hybridization, but I will say hybridization will come under tendency to form different bonds. When you say single bond, we say the hybridization is sp3. Whenever it forms double bond, we say the hybridization is sp2, and whenever they form triple bond, we say the hybridization is sp. Understood? So it is a subcategory of tendency to form multiple bonds. So generally 4 reasons are there. One is tetravalent, next one tendency to form multiple bonds, and third one it's tetrahedral shape, and the last one the catenation. Okay, in the next section we will try to understand how to do nomenclature of organic compound, how to put name for organic compounds, what are the different types of naming in organic compounds. Okay, thereafter we will go into detail of hybridization and then aromaticity. I hope you understood the lecture. If you have any doubt, please get back to us. Thank you.